Second part of the chapter 11 is the definition of a duration. Duration of the measure of, actually, the effective bond maturity. So what is effective bond maturity? So we have bond maturity like 30 years, 2 years, 1 year, that's maturity, nominal maturity. But because we receive coupon, bond actually effectively mature before the maturity date. So duration measures the effective bond maturity date. It's weighted average of times until each payment with weights proportional to the present value of the payments. So it's hard to understand. So when I show how to calculate, you may be able to understand more detail better. So this weight of each time is the cash flow T divided by 1 plus Y to the Tth, which means this is the present value of each cash flow, right? Cash flow times T. So present value of cash flow times T divided by bond price. So this weight is weight of cash flow relative to the total price. And the duration is now the T is the time times this weight and add them up. That's duration. So let's look at how to calculate it. So this is the spreadsheet of the duration. Let's look at more detail about that. So let's continue to the show the duration part. Yes. Oh, not this one, I'm sorry. Let's look at this spreadsheet. Yes. Okay, we see that. Yeah, this is the spreadsheet from the, so this is spreadsheet from the PowerPoint slide. So you can, if you double click the PowerPoint slide, the Excel icon, then you can, this spreadsheet popped up. So the first case is 8% coupon bond, 3-year bonds, 10% yield, and it's annual coupon. So the payment in each year is $80, $80, and $80, right? I mean, $1,080 because $1,000 per value also should be included. Now, because we have to calculate the present value of in each, so first one is calculate the present value of in each. So the payment divided by 1 plus interest rate and power to the number of years, right? Same thing for the next 3 years. So second one is the C7, the payment to cash flow to divide by 1 plus Y, the interest rate square. So the present value of this $80 cash flow. Third one is present value of the third year cash flow. And if you add them up, and that will be the price of the bonds, right? So that will be the price of the bonds. So this is the price. Because we have price, now we can calculate the weight. So first, cash flow, present value cash flow divided by the price. Second one divided by the price. And the third one divided by the price. And that's each weight. And if you add this up, you should have 1, right? That should be the weight. Now the final part is we need to multiply this number, the time until payments. So first year times each weight and to the end. So second one is the time 2 times this weight, and third one is time 3 times this weight. And if you add them up, that will be the duration. So duration is 2.7774 years, about 2.78 years is the effective maturity of these bonds. Now, the next one is the zero coupon bonds. The zero coupon bond, we will do exactly same way. So that because this doesn't have any coupon, we have $0, $0, and $1,000 par value, right? Then if you calculate this exactly same way, again, then $0, $0, because there's nothing, and the only cash flow 1,000 divided by 1 plus 10% to the third, and if you add them up, that's the price, and the price is exactly same as the last year cash flows, right? So weight is also simple. Weight is 0, 0, 1 because there's nothing here. So some of this should be 1, right? And then if you calculate the duration, then the duration is same as the maturity. So zero coupon bond duration is the maximum duration you can have, because effectively, I mean, the longest one you can have is probably the one that same as, like the whose maturity is same as basically effective maturity, right? So the maximum duration is its own maturity, and which happen only for zero coupon bond. Okay. So that's how to calculate the duration using the spreadsheet. Now we will have another example here using the duration too. Now the thing that we make duration matter is the duration may be not just effective maturity, but can explain very important information, which is interest rate risk. That's what we'll see. So from the formula here, this delta is a change in price, okay? The delta means change. So delta P divided by P is, delta P is the price changes divided by P, which is percentage change in price, right? Equals to negative duration times delta 1 plus y, y is again yield, divided by 1 plus y. So this is actually percentage change in 1 plus interest rate. At least we can see that, well, interest rate changes are inversely related to the price changes, right? And if duration high, then it's more sensitive. That's what it means. So how to derive this formula? This is a little calculus stuff. So I will solve this one. You don't have to really know the detail like solution, but I will. If you're if you're good at calculus, then you may be able to understand better actually. So it's not required, but I'm going to show. So this actually starts from the price function. So we know that the price equals to, right? So price of the bond is sum of the present value of cash flow, right? So this T to T is first year to maturity. Let's actually change the color. So again, the price equals to sum of T equals to maturity date. Cash flow each time plus 1 plus Y, which is yield to the T's, right? That's the price. Now let's take a derivative is relative to, so delta P times 1 plus Y. 1 plus Y. So this is actually also, you can just write like delta P and delta 1 plus Y, okay? It's actually equals to, it's a little rewrites. We can rewrite this equals to sum of cash flow T times 1 plus Y to the negative T's, right? And we know that, so we take a derivative with respect to the 1 plus Y. So what we gonna have is the sum of negative T times cash flow T times 1 plus Y to the negative T minus 1. So if you take the parentheses, then this is negative T plus 1. So this changes to actually 1 over 1 plus Y to the T plus 1, right? We can also rewrite this equals to negative T equals to 1 to T times cash flow T times. So let's take 1 over YT, then times 1 over 1 plus Y to the 1 first, right? So that we have 1 plus YT plus 1 is denominator. Now let's find the definition of the duration. We know that the duration equals to sum of T times weight T, and where weight T equals to cash flow T divided by 1 plus Y to T divided by the price, right? So we can rewrite this sum of T plus T times cash flow T divided by 1 plus Y T times 1 over P, right? Just to plug into formula here. So this is weight. From this, we can rewrite this actually now. D times P equals to, so P, you can actually go here, equals to sum of T times cash flow T divided by 1 plus YT. So that's the D times P. Now let's go back to the first one, this one, and these can be found here, right? This one. And because this 1 over 1 minus 1 plus Y is constant, you can take it out. So now delta P divided by delta 1 plus Y equals to negative 1 over 1 plus Y times, this is just a D times P, right? So we can rearrange this one as delta P divided by P equals to negative duration times delta 1 plus y divided by 1 plus y. Right? So that's the proof of that. Proof that, well, percentage change in price equals to negative delta times delta 1 plus y, which is the change in 1 plus interest rate divided by 1 plus interest rate. Now, this is a little tricky because we usually are interested in that, well, if the yield change in 1% point, how much price changes? So from this, so we can keep this one. And we have little different measure to make our calculation easier to directly show the interest rate risk using this duration. Okay. I mean, again, you don't have to really mathematically derive this. I'm just showing it. So if you are good at calculus, then it's probably worth to show once, but I'm not going to ask in exam. Anyway, just to remember the formula. So from this, let's define another measure called the D star. And D star equals to 1 of, actually, I'm sorry. D star equals to D duration divided by 1 plus y, okay? And let's plug. So from this, again, delta P divided by P equals 2. Now, negative D divided by 1 plus y times delta 1 plus y. Now, because delta 1 plus y should be same as delta y, because this one always just cancels out for changes, right? So such as if your interest rate changes 1% to 2%, then delta y is simple, 1% minus 2%, which is 0.01, right? 1 plus y is 1.01 to 1.02. I'm sorry, actually change is 2 minus 1, right? So positive 1%. So 1.02 minus 1.01, which is same 0.01. So delta 1 plus y is same as delta y. So we can rewrite this just because this is D star, so D star times delta y. And this measure is more easier to understand because this is percentage change in price, so like 10% price change, things like that. This delta y is the just interest rate changes. You can actually see, so if the interest rate change 1% to 2%, this should be 1% point, 1%, right? So this D star directly represent how much percent of the price changes if interest rate changes. So, right? So especially 1% point changes. So if delta y is say 1%, then you can say that, well, this price change is the price changes per 1% changes. And this delta star is called the modified duration. Again, this modified duration, if the modified duration is higher, then it's more sensitive. So it's that more, if bond has higher interest rate risk, then D star is higher. Obviously, because D star equals to 1 D divided by 1 plus y, which means that this D duration is also called the Macaulay duration. Macaulay duration also represent the degree of the risk, but if we have the modified duration, it is more directly shown. So if you go back to the slide now, we have modified duration. And this is the duration, modified duration equals to duration divided by 1 plus y. Then you can directly see the price changes. So again, if you look at the spreadsheet again, okay. So I'm going to show the spreadsheet. Yes, here. So now we have a little easier function for duration. So like bonds. So if you see the duration settlement date, so this is 3 years, so we can just easily formulate the 3 years from 2000 to 2003. You don't have to do it, but this is probably the easiest way. This is 3 year, 8% coupon, 10% yield. Coupon per year is 1. Then your Macaulay duration can be calculated by this duration function. So called the duration. And the first one is the settlement. Second one is maturity. The third one is coupon yield and coupon per year. Then you can get the duration. So you don't have to have like the calculate complicated way. I mean, I recommend again still to practice using the previous spreadsheet, because this is the previous spreadsheet make you understand duration better. But when you really use Excel to get the duration, you just use this duration function. Now the modified duration is also, we have a function called the M duration. Same thing. Oh, I'm sorry. Should be same. 3, 4, 5, 6. Then this is 2.5249. Should be same as. So this should be same as. As you see, this should be same as that. Well, the Macaulay duration divided by 1 plus interest rate, right? Still same numbers. This is 2.5249, right? So we can just verify that. So you can use the duration function or M duration function to get the Macaulay duration and modified duration. So let's continue. So duration, the example 11.1, the duration and the interest rate risk. So if the bond has a maturity 30 years, coupon 8% if it is paid annually, and the ultimate maturity 9%. Its price is $897.26, and you can verify that. If you calculate the duration is 11.37. What will happen to the bond price if the bond yield to maturity increase to 9.1%? So 9.1% means that it's increased actually from 9% to the 9.1%, so 0.1% point increase, which means delta y equals to 0.001, right? Which means that we know that we need to calculate the modified duration equals to duration divided by 1 plus y. So 11.37 divided by 1 plus 9%. So that one, and negative, and the change is the 0.001 percent point, and that's the percentage price changes. Now times price, then you can get new price changes, right? So because the delta P times P equals to negative D star modified duration times delta Y. So delta P price change equals to modified duration times delta Y, the interest rate changes times the price. So it decreased by $9.36. So that's the relation between the duration and the interest rate risk. If the duration is high, then interest risk is high. Interest rate risk is high. So this is duration function of the maturity. As you see, this function clearly shows very consistent result as we saw the first slide, the relation between interest rate and the price. And you clearly see that the zero coupon bond duration is the highest. So these are the determinants of the duration. Number one, zero coupon bond duration is time to maturity. The 3 years zero coupon bond duration is 3 years. Time to yield to maturity is constant. Bond duration and interest rate sensitivity is higher when coupon price lower. So interest rate sensitivity is higher when the coupon is lower, right? So same as the duration should be higher too. If coupon rate is sensitive, is constant, bond duration and interest rate sensitivity generally increase with time to maturity. Usually longer term bond, higher interest rate risk, so bond duration also high. The duration always increases maturity for bonds at or above par. Okay, so if the bond is par bond or the premium bond, it always increases. Other factors constant, duration, interest rate sensitivity to the coupon bond higher when bond yield to maturity is lower. So it's basically exactly same explanation that we saw in the first one, because we saw that well, when YTM is lower, then the interest rate sensitivity is higher, which means duration should be higher. Finally, we also can calculate the duration of the perpetuity. So this perpetuity means never be matured. So duration of the perpetuity is just it's just formula 1 plus y divided by y. So if y is 10%, then 1 plus 10% divided by 10%, which is 11 years, is duration of the perpetuity, 10% perpetuity. So this is annual coupon bond duration. You can see the consistent result as we saw in the previous slide. And you can see the infinite, like perpetuity duration is 1 plus 6% divided by 6%, which is 17.67. Okay, so that's how to calculate the duration.